by my computer over here. All right, so we are multiplying monomials. What is a monomial? Well, what does this prefix mono mean? One. It means one. And then this second part we got terms. So we're talking about things that are one term. Now, in contrast to one term, we have we have a binomial right here, which has two terms. One term, two term. M to the third is a monomial because there's only one term. And terms will always be separated by an addition or a subtraction sign. So we have a monomial here and a monomial here. And we are going to multiply the two monomials together. So, Alex, what is another way of saying m to the third power? How could I write m to the third power in expanded form? M times m times m is in fact m to the third power. All right, and we are going to multiply to that m to the fourth. What's another way of saying m to the fourth? It's best when multiple people answer the same question at one time because that works really well in online school. Don't you all agree? Yeah. It actually makes it kind of fun. The best is, have you guys ever tried singing as a group online? Yeah? Oh, it's Daniel's birthday! Do we need to sing happy? What do you think, Class A? Should we sing happy birthday to Daniel? C or no? I heard that as a C.
Me too.
Okay, so everyone unmute yourself. I'll pause the video because nobody needs to listen to me sing happy birthday. All right, so if I have m times m times m times m times m times m times n, how many m's are we multiplying together? 7. So this is equal to m to the 7th power, because 7th power means you're multiplying the same thing 7 times together. So the big takeaway from this is, what did we do with 3 and what did we do with 4 that resulted in the 7? We added them. We added 3 plus 4 to get 7. Okay, great. So that takes us to our rule. And our rule says, there we go. Our rule says that if you're multiplying two terms that have the same base, in this case a base of a, then you will add the exponents. So a to the x times a to the y is equal to the a to the x plus y. And you just prove that by saying m to the third times m to the fourth is equal to m to the 7th. The bases were the same. They were m's. And so we combined the exponents. And we knew that because by expanding m to the third and expanding m to the fourth, we got m to the 7th. Okay, we're doing yoga over there. Everything going okay? Okay. The Hicks house is doing yoga during math. I love it. All right, so in honor of Daniel's birthday, I was going to do Josie, but here we go, Daniel. Daniel, what's your favorite number? 8. All right, were you born on the 8th? No, I should have known that. It's the 12th. And it's not even the 8th month. Okay. All right, so Daniel's favorite number is 8. We're going to multiply Daniel to the 8th times Daniel to the 12th, because today is the 12th. What do we get when we multiply d to the 8th times d to the 12th? Daniel to the 20th, because we added the exponents together. All right, let's try another one. Let's say we have Daniel times Daniel to the 8th. Daniel to the 9th, because when we have a variable with no exponent specified, it is always going to be a 1. Okay? All right, so let's try a new one. This time, let's try Daniel to the 8th long. I don't like my L, so I'm going to redo it. Times Daniel to the 7th long to the 4th. I'll give you 5 seconds to think about it. All right. Daniel to the 8th times Daniel to the 7th. So we're going to multiply the same bases, the things with the same base. What's d to the 8th times d to the 7th? d to the 15th, right? 7 plus 8 is 15. Okay. If I have long times long to the 4th, how many longs do I have? Long to the 5th. Okay, perfect. All right, let's try this one. Let's go d to the 3rd long to the 4th times Daniel long to the 5th. Yes. It is always a positive 1 if there's no exponent labeled there. That is a good question. All right, so what do we get? How many Daniels and longs do we have? I think it's only fair that we ask the birthday boy in the flesh. Daniel, what is the answer to our Daniel long problem? Okay. All right. Excellent. One more problem. Let's say we have, and I'll simplify it. Let's say I have a long family. How many sibs do you have, Daniel? You have 2. So let's say we have Daniel to the 4th times, long to the 4th times long to the -2nd. What will we have now? Grab this one earlier.
You've done it all classes.
I know, but I forgot. I normally did it earlier.
Oh, okay.
So what will I get here, folks? I do need a volunteer here.
I have no hands up. Oh.
You would get long to the 2nd, because even though you have a negative here, you still add them together. 4 plus -2 is 2. All right. All right. So there we have it. The next question, Daniel, what is your middle initial? If you want to tell us your middle name, we'll take that too. But I do need your middle initial. Charles, all right. I believe that starts with a C. Thank you for confirming that. So we have d squared c long to the 4th times, let's go with, sometimes Daniel forgets to sign things with his middle name, so we'll go Daniel to the 3rd long to the 4th again. So what do I get when I multiply these two things together? What do I get when I multiply these two things together? Do I have a volunteer? I love this volunteers tribute thing. All right, so Gavin, what did you get? Perfect. So just because there's no C here doesn't mean that it disappears. We have this one here. Now, in the last algebra sheet, you could not add or subtract things that were different in any way when it came to the variables and the exponents. You can multiply or divide anything you wish. That's fine. But adding and subtracting, it must be identical letters, identical exponents. So do we have that distinction, this differentiation? Yes, no, maybe so?
What is that?
Okay. All right. No, I'm actually, this is a good question, and I'm glad that you asked it while I'm recording, because I know that there are others with the same question. Here's what's actually happening. D squared is D times D. C is just C. L to the fourth is L times L times L times L. Then we have the big multiplications, and then D to the third is just D times D times D. I'm probably going to run out of room. Times L times even skinnier L times L. So, okay, how many D's are we multiplying together? Well, those two, these three, so that's D to the fifth. I only have this one C. And I have 1, 2, 3, 4, 5, 6, 7, 8 L's. And most of you will tell me that I did not put D, C, and L in alphabetic order, and you're absolutely right, I should. However, that's not his initials. So I'm going with his initials. That's the way it goes. So, Abby, did that fully answer your question? Okay, perfect. So I would like you to try to do these two problems here. Now I understand that it is fairly hard to see it on the Google Meet, so I will write it a little bit larger so that hopefully it is easier to read. And this one is
Kids are getting kicked out left and right, but they are coming back.
Thank you for your perseverance. I do appreciate it.
And Clara's computer just crashed. So Clara is not here.
Okay. So this should take another 30 seconds.
Are you good for a few minutes? I have to go down and get some.
Yes, I'm good. Mondays are good days. I mean, I barely looked at the screen today.
Yep.
Which makes for a really good much better day.
I'll be right back.
Okay.
I just have to get
But I will
this.
miss you with every part of my
Oh, that's okay.
All right, guys. So what did we get for the first problem? I need someone to volunteer. Is that Allison? Emerson. Okay, Emerson. Let's go. I'm just going to repeat what you just said for the posterity's sake. You said that a to the first times a to the sixth is a to the seventh because 1 plus 6 is 7. Okay. And I'm going to do that for each piece, so don't think that you did anything wrong. Okay? So b to the second times b to the fourth is 2 plus 4 is 6, since we're multiplying monomials. Okay? So c to the third times c to the second, 3 plus 2 is 5, so we get c to the fifth. C to the fifth. Now here's an important thing that sometimes kids get lose track of. This 7th power is only for the a. The 6th power is only for the b, and the 5th power is only to the c. That's a big important thing. All right, Emerson, could you please pick another volunteer as tribute? Which Caroline? We have 2 of them. Okay, so this is not the one that I can sing the song to. But speaking of Caroline May, I do have a question before we move on. Caroline May, does this look familiar to you? Or your brother? Okay. Well, I will bring it to cross country then. Okay. All right, go for it. You multiplied. Okay. F to the 11th. So f to the 9th times f to the 2nd. You add the exponents even though you're multiplying the terms, and you get f to the 11th. Okay. Okay. G to the 3rd, because 1 plus 2 is 3. All right. Okay, there we go. So your algebra sheet this week will be on this type of stuff. We'll be multiplying monomials together. This will be, if you get it, this algebra sheet will be very, very fast. If you're struggling a bit, it'll take like that. Yes? It's not there. It's not there. I don't have a scanner at home, so I have to scan it when I get to school. And I had a parent conference at my first planning period, and during lunch we had a monstrosity of a meeting. So I haven't gotten to scan it yet. That's why it's... No, really, I haven't put a new one up this way. Well, let's not worry about it. I will put a new folder from the algebra sheet folder, I promise. Yes, that is your constructed response items. Okay, so moving on. All right, so today we are looking at growth in exponential relationships, and we are going to be comparing growth. And actually, we are going to spend 2 days on this investigation, and we are also going to answer the question, why was there a teacher's strike 2 years ago? And this investigation, the actual investigation happened to me in DPS downtown headquarters when it came to them trying to get me to switch my pay structure. So this actually can happen to you, so hopefully you do not get bamboozled and tricked out of tens of thousands of dollars. All right, so we're making new offers. And last time we were with the king and the son who was pulled out of the water by a benevolent and wickedly smart peasant. The king had promised more money than he had in the royal treasury to the peasant. But he hasn't figured this out yet. He thinks he's only giving the peasant a few pennies. So he goes home in the carriage with his son after being very relieved that his son was alive. He was very angry. But whatever, he went to the castle. He said, "Queen, you will not believe what had happened." She tells the story of the son running away, of the peasant saving the kid's life, and then he tells of the small reward of a few pennies that the peasant has asked for. Now, the queen is a very smart woman, and it doesn't take her long to realize, you idiots! You've promised her more money than we have in the treasury. That's it. You're grounded. Go up to your room this instant until you figure out a new plan that's going to get you out of this mess. Go, now. Get out of here. How many of you have had your mother yell like that at you? Me? Yeah. Me too. That's why I moved away from home. Not really. Okay, kind of. All right, so the king goes into his room and he devises a new plan, a brand new plan. And here's his plan. He was shocked at how much doubling could really become over 64 times. So what happens if we reduce the amount of doublings? So instead of a 64 square chessboard, he's going to go with a 16 square chessboard. But obviously the peasant is not going to agree to that. Oh no. So he has to come up with another way to make it look more appealing. So instead of doubling, he is going to triple each square. So if the first square gets 1, the second square will get 3. How much will the third square get? Oh my goodness. I smell something in the air. I smell a table too! No way! We all smell the same thing in different places. That's actually really cool. I'm going to save this table for later. Alright. Oh, we don't want that. Okay, so we're going to make a table, and we're going to make our life a little bit easier. We're going to have to recall the peasant's plan too. So we're going to include the peasant's plan. Now, as part of your investigation, you're going to have to go from square 0 to square 10. But I'm only going to show right now from square 0 to square 5. And I'm going to add some extra squares too. So you might want to follow my table first, and then you can add extra things later. So we're going to call the peasant's plan. Oh, I don't know how to spell peasant. We're going to call this plan 1. And how many squares were in plan 1? 64. So there are 64 squares. I'll do squares in orange. How many, so what are we doing each square? We're doubling, okay, so we're doubling. So we're doing times 2, doubling, okay. And so we also have the square number. And we're going to start at 0, 1, 2, 3, 4, 5. And so we're going to make our table. Yes, we need to make it that large. You saw the other class's table, and it's going to be big. All right, and I'm going to include a little bit extra. All right, so how many pennies were on the first square of the peasant's plan? 1. All right. How many were on the second square? 2. How many on the third square? Not a trick. 4. Fourth square? Fifth square? Okay. And we had an equation. So what was the equation that we had for the peasant's plan? 2 to the x power, but that's not the whole thing, because 2 to the second power is 4, but on the second square we only have 2. Okay, and the minus 1 was in the exponent. We definitely need to make sure it's in the exponent, okay. And also we had another equation that we said it was equivalent. We said 1/2 times 2 to the x power as well. All right, and what was at the 0th square? How many pennies were in the 0th square? No. 1/2. We had 1/2. Okay, and then in the king's plan, we're going to call that plan 2 also. We had how many squares? 16. So we definitely need 16. And what are we multiplying by? We're multiplying by 3. Okay. All right. And so in the king's plan, how many pennies did we have in the first square? No. 1. We had 1. How many were in the second square? 3. Okay. How about the third square? 9. Thank you for not saying 6. It was tempting. The fourth square? The fifth square? 81. 81. All right, there you go. All right, and we'll talk about the equation in a second. Or I don't know, what do you think the equation should be based on the peasant's plan equation? It would still be -1. The only thing that's changed is how it's growing. That's the only thing that's changed. What is the y-intercept? It would be 1/3. And so our other way of writing this equation would actually be 1/3 times 3 to the x power. Oh wait, no way. The y-intercept showed up in the equation again! It's almost like it is supposed to. All right, so he's very excited. He goes down to his queen and says, "Queen, I found a new plan. I'll have 16 squares and I'll triple it and I'll trick her into taking them." But the queen, she doesn't want to pay anything really. So she's like, no. We're going to give her 12 squares. And on top of the 12 squares, we are going to use the equation P is equal to 4 to the n minus 1 power to continue the growth on our 12 square board. Done. So, the queen's plan, she'll be pink. So the queen's plan, we're going to call this 3. Now, if I'm writing it, what are you doing? Okay. And so how many squares? 12, okay. And so she said that her equation is 4 to the x minus 1 power. So what are we multiplying by every time? All right. So if there's 1 on the first square for the queen's plan, how many are there on the second? How about the third square? 16. On the fourth square there is, there you go, 64 and then 256. All right, how many are on the 0th square? 1/4. All right, so what's the other equation that we can write for this? All right. Yes? Okay, yeah, I'll help. 1 times 4 is 4. 4 times 4 is? Yes, that is, well, I am involving the x in that I'm using this equation here. I'm doing 4 to the third power. 4 to the third power is 4 times 4 times 4, which is 64. But then I am dividing or multiplying by 1/4. I'm sorry, I couldn't hear what you were saying because I was too busy yapping. I'm sorry. Oh, yes. No, that's not going to work out so well. Yeah, so the important thing is the x value, the independent variable, will be plugged in for the x. And so it's an exponent, not a multiplication problem. All right, so here's where we are. It is 1:55. You have a small number of ACE problems due. Let's go check that out, shall we? I think it's that one. All right. So, the ACE problems that you have due tomorrow are not. Yes, they are. Oh my goodness. Okay. So your ACE problems due tomorrow are 1, 1, and then 22 through 27. I would also very much appreciate it if you could make a graph. I do need you to make a graph out of this table. Just to make your table go a little bit quicker, I said to go from 0 to 10. I feel badly for that, so let's go from 0 to 5. 0 to 5. And I just want you to make a graph of the values with a domain of 0 to 5. Does that make sense? So I want this, and I'll be very specific. I want one grid. I want exactly one grid. I do not want you to make multiple grids. I want you to make one grid. And on this one grid, you will have multiple curves. And it's not going to look like that. I did that on purpose. Does that make sense? You're going to have one curve for the peasants plan, or one curve for the kings, and one curve for the queens. And please use different colors. That'd be great. Okay? All right. I hope you all have a wonderful day. Okay, see you guys.